right, so we got a triangle here, we got a proof. These are the worst things ever because this is not how any sane person should teach you to do a proof. All right, with this T-chart stupidity, jamming all of the givens into one statement. It's just not the way to do a proof. But we get these once in a while, so we had to make do with them. All right. So I just kind of look at this stuff and I see if I can figure out what's going on. So it says BD is equal to BD. I'm going to write down anything equals itself. Okay. So I've got congruent triangles, and the next step says AD is congruent to CD. So let's make sure we know where the congruent triangles are. So ABD is this one, and the CBD is this one. All right, and then it's telling me that AD is the same as that. And it's telling me that that is the same as that. So that's going to be corresponding parts of congruent triangles are congruent for sure, okay, because that's almost always the step after the triangles there anyways. And then it says BDE is the perpendicular bisector of AC. All right, let's see. I'm just trying to scan through what they've got here. So let's add all the stuff they had on there. All right, so they had ABE, which is this angle up here, is the same as CBE. And they had ADE, which is this angle here, is the same as CDE, which is that angle there. Okay. All right, and then they did this right here so that they had, okay, I see what they did. So then they had, I gotta move my things here a little bit when I moved this stuff. All right, so it had that's the same as that, and then it ended up with this is the same as this, which gave them angle side angle. Okay, now they're trying to say that this line down the middle right here is the perpendicular bisector. So perpendicular bisector of this bottom line. All right, and what they're doing is this is a isosceles triangle. All right, so I'm going to type this off to the side here. I'm going to say since triangle ABC has equal legs, it is isosceles, and BDE bisects the vertex angle, so it also bisects and is perpendicular to the base. You need to say something about the fact that once you know it's an isosceles triangle, the line that cuts anything in the middle in half cuts everything in half because it splits the triangles directly down the middle. All right, you could play around and make more equal triangles to do it, but the way that they have this proof written, that's what they want you to come up with, is that that line cuts the vertex angle in half, so it also has to be the perpendicular bisector of the base. That's the answer they're looking for. Holy